Good morning. I'm Dr. Palash from Department of Electrical Engineering. Today I shall discuss about the different types of transmission line. Because in previous class I discussed about the performance, that means regulation and efficiency, how we calculate the performance and regulation of a transmission line. So in addition with this, because you know the performance of transmission line will depend on according to based on the length of the line and how much voltage is associated with the line. So based on this, the your transmission line is classified in three categories. Classification of transmission line. Number one is short transmission line. Number two is medium transmission line. Number three is long transmission line. As the short transmission line is length is very small and voltage is also very small. Based on this, as three parameters are there: resistance, inductance, and capacitance. So here we consider the capacitance as a lumped parameter. Only consider the line has some resistance and inductance. In medium transmission line, here the length of the transmission line is basically in between 50 to 150 kilometers. And capacitance, as the length of the transmission line is increased, so we consider the capacitance is formed in between the conductor. So based on this, the consideration of the capacitance, again the medium transmission line is classified, so that will come later. So first we discuss about the different types of transmission line. In long transmission line, here all the line parameters, resistance, inductance, and capacitance are considered in calculation when we design the line and when we analyze the regulation and the efficiency of a transmission line. So first I am considering the short transmission line, how the short transmission line will work and how we calculate the efficiency and how we calculate the regulation of the transmission line. Short transmission line. Here this. Okay. Okay. See. As the length of the transmission line is less, which is up to 50 kilometers and voltage is on an around 21 kV. So here you only consider the resistance and the line inductance will come in the calculation. So the input voltage is considered as the sending end voltage and the receiving end voltage is considered as the VR. Corresponding input current is called the sending end current and the output current is called the receiving end current. Now, first we will draw the phasor diagram. of the particular transmission line. See. Here I am considering, suppose this is I. This is lagging because this is like as a RL circuit, so lagging. Here I consider the VR is the receiving end voltage. VR is the receiving end voltage. And the angle between current and voltage we considered as this is your phi R. That means receiving end power factor, phase angle. When IS current is passing through the resistance and the inductance, so obviously here the IR drop will happen, and here the IXL drop will happen. So here you consider this is your the IR drop. IR drop means resistive drop, and here I consider this is which drop? IX, that means inductive reactance drop, and afterward I'll get the voltage which is VS, sending end voltage. Okay, and the angle between the current and the VS, which is represented as IS, sending end phase angle. Okay. Here I have written the I is in the axis. I means here as sending end current and receiving current is same, because this is a series circuit. So current flowing through each and every component is same. So here I can consider the IA is equal to IR equal to I say. That's why I am considering here I here. Okay. Now see here I am considering this is, and here is created two component here. One is here I can say this is your VR cos phi r, and this is your IR. First keep a nomenclature. This is O, A, B, C, D. Okay. Very simple equation. Here I consider only say hypotenuse square equal to base square plus perpendicular square. That means hypotenuse square means here OB square, base is OA square plus perpendicular square, which is AB square. Now here OB means okay, I am writing here, this is OB square. OA means OC plus CA square plus AB means AD plus DB square. AD plus DB square. OB means, what is the value of OB? Which is VS square. OC means, if I create the two component of VR, so this will come VR cos phi r and this will come VR sin phi r. So here I will write this is VR cos phi r plus IR square, and this is AD. AD means up to this. That means this is VR sin phi r. This is VR sin phi r plus dB. That means IS square. So in this way, we can calculate the sending end voltage. Okay, Vs means sending end voltage. Okay, it will better for you. I am giving the all nomenclature here. Here Is is the sending end current, IR is the receiving end current, Vs is the sending end voltage, VR is the sending end, VR is the receiving end voltage. Receiving end voltage. And here fire is the receiving end phase angle, phi s is the sending end phase angle. Okay. See. So in this way you can calculate Vs. Now when I want to calculate its suppose power factor or phase angle, then from here we can also calculate by considering this divided by this. So in this way. Now regulation. How we calculate the regulation? Regulation means percentage regulation. Vs minus Vr divided by Vs multiplied by 100. Okay. If I want to calculate efficiency, all things we can calculate. Efficiency, percentage efficiency. Then we can calculate as you see. So this is the part efficiency. That means this is, if I consider the receiving end, or say this is your sending end, that means it will come your, what is the efficiency? That means output divided by input. Efficiency means, okay, I am writing here, output divided by input multiplied by 100. Or also we can represent, this is your output divided by output plus losses, line losses multiplied by 100. Also we can write output means VR, because IR is the current, this is your cos phi r divided by VR IR cos phi r plus I square Z. Z is the impedance. Okay. And also we can write in another way. Also we can write, see, your VR IR cos phi r is the input output, and input is Vs Is cos phi s. Cos phi s multiplied by 100. So in this way we can calculate the efficiency. Okay. Now this is the one way we can calculate, or we can show the expression of the short transmission line. In another way, there is another way also there. Another way means by using by graphical representation. See, I am just drawing here by considering the graphical representation. This is this, and this is this. this is your fire. So here this angle will be fire. That means IR will create two component, and this angle also will be fire, because all angles. So here also I can write, you see, this is your IR cos fire, and this is your IR sin fire. Okay. And this is your IX cos fire, this is your IX sin fire. Okay. In this way, we consider this. In this way, we can follow. So Vs is approximately equal to VR plus IR cos fire plus IX sin fire. Okay. Same thing I will write in this expression. So we can write Vs is approximately equal to VR plus IR cos fire plus sorry, not IR here, IR cos fire, and this is IX sin fire. Okay. And again we can write Vs minus VR, that means sending end, the difference between sending end voltage and the receiving end voltage is approximately equal to, this is IR cos fire plus this is your IX sin fire. Okay. If you want to go for identification of the regulation from here, what is regulation? Regulation, percentage regulation, well, I've written here, this is your Vs minus VR divided by VR multiplied by 100. Okay, same thing, I'll just put here, regulation. Okay, percentage regulation is approximately, this is approximated equation, because we have not considered here, due to the short transmission line, due to the short of the length, we have not considered the capacitance here. Only we consider the resistance and the inductive reactance of the transmission line. Okay, so here I can write here, this is your IR cos fire divided by VR, this is your plus IX sin fire divided by VR. Okay. Multiplied by 100. Here, see, the thing is that as you get this IR divided by VR, so this is called the resistive drop percentage. This is a resistive drop. This is VR and this. So here we can write here, this is called VR is the drop. Okay, cos fire plus this is called Vx sin fire. Okay. See, VR means what? VR means IR divided by VR multiplied by 100. Okay. And this VR is known as percentage drop. Okay. So if required to determine the percentage resistive drop and the percentage inductive reactance drop, you can calculate from here also. So this is actually main target of the regulation. So here VR is the percentage resistive drop and Vx is the percentage inductive reactance drop. So in this way, by taking this, we can calculate the regulation of the short transmission line. Okay, as you get. Now the fact is that the the efficiency. How we calculate the efficiency? We can calculate the efficiency by taking, see the efficiency can be calculated by efficiency means percentage efficiency equal to what is the output power? Output is VR IR cos phi r divided by the input. Input is Vs Is cos phi s multiplied by 100. Okay. So this is the way to calculate the efficiency. Now the fact is that as we get the from the short transmission line, we are getting the regulation and we are getting the efficiency, and also we can calculate the ABCD parameter. Right. This network is like this. See, if I draw again the circuit, this is your resistance, this is your inductive reactance, this is your input, and this is your output. If I consider this is the network, this is the network, so this is the input and this is the output. If the input is your Vs voltage and this is your Is is the sending end current. Okay, and this is your receiving end current and this is your Vr is the receiving end voltage. Okay, so this is a network, this is like as the two-port network. So in this way, if I consider the two-port network here, suppose here if I write again, this is A, B, C, D. If I want to calculate these parameters, so easily we can calculate the parameter like this from here. How we calculate for short transmission line? This is the input voltage. Input voltage is the sending end voltage. This is your output voltage. Output is your receiving end voltage. This is receiving current, sending end current. Right. So the network can be represented as, if I put a matrix, this is Vs and this is Is, which is equal to A, B, C, D, and this is your output is Vr, IR. And from here we can write this is Vs equal to A Vr plus B IR, and I is equal to C Vr plus D IR. Now we need to identify what are the parameters A, B, C, D. Why we need to calculate this? Because from their conditions we can see whether the network is the symmetry or your reciprocity. We can see from the ABCD parameter. Now see, okay, see, okay. So if for this case, we need to consider some conditions. Suppose the network is in open circuit condition. Suppose the network is in short circuit condition. When the open circuit condition, that means your VR is 0. Open circuit condition, your IR is 0. And corresponding the short circuit condition, the IR will be exist here. You see, so considering the short circuit condition, see, in short circuit condition, what will happen? short circuit, that means IR will be exist, VR will get 0. Okay. So see, that means IR ideally is infinity and VR equal to 0. So in this equation, if we put the VR is 0, so corresponding what you will get? So we can write Vs equal to, see, VR part is 0, so sorry, VR part is 0, so that means we can write see, Vs equal to VIR, Vs equal to VIR. That means your V equal to Vs divided by IR. Okay. From the another equation, see, Is equal to, this part is 0. So we can write D equal to Is divided by IR. Directly I am writing here. Okay. So here again I am writing D equal to what? Is divided by IR. Okay. Is divided by IR. Okay. Similarly, considering open circuit condition, in open circuit condition, that means what happened? The IR will get 0, but VR will exist. Okay. So from this equation, if IR is 0, so from here I can write Vs equal to Vs divided by VR. So A equal to Vs divided by VR. Okay. And further C equal to Is divided by VR. Further C equal to Is divided by VR. Okay. Is divided by VR. So from here, see, we need to we can represent the parameter A, B, C, D. Okay. A means Vs divided by VR. Vs divided by VR means this is represent the gain of voltage. What voltage you are getting from what voltage you are giving input and what voltage you are getting output. That means this is called voltage gain. Corresponding, the D is Is divided by R. What current you are entering in the circuit and what current getting from the circuit output side. So this is called the current gain. Okay. And here see, this is Vs divided by IR. B is, that means this is called B, that means J equal to V divided by, that means this is called the from the input voltage to the output current. That means this is called transfer impedance. Okay. And if you see C is Is divided by VR, that means this is your transfer admittance. Okay. So this is the representation of ABCD parameter. Now, if you go to the short transmission line circuit, see, again I am drawing here the circuitry which will suppose this is your sending end voltage and this is your receiving end voltage, this is your receiving end current and this is your sending end current. Okay, sending end current. This is your resistance, this is your inductive reactance, and this part is called your Z. Z is the impedance of the circuit. So what I can write from here? I can write from here. See, I am showing here. So is equal to IR. I is equal to IR. One expression with IS. See, I is equal to C VR plus D IR. Okay, one expression I get. And another expression you can write Vs equal to C VR plus IS or IR, whatever you can write, Z. Now you see the coefficient of this thing, coefficient of Vs equal to A VR plus B IR. That means what is the value of A? A is 1. A is 1. What is the value of B? B is, see, B IR, that means this is your Z. Okay, A VR plus B IR. Corresponding here, see, I is equal to C VR plus D IR. See, I is equal to C VR plus D IR. That means for that case, in short transmission line, this part is not in there. That means the C is 0 and D. See, that means your C is 0. D, what is the value of D? The coefficient of D? Coefficient of D is 1. Okay. Now, if you want to go for calculation, the condition of symmetry is AD minus BC equal to 1. So you check it. AD means your 1 minus BC, that means 0. So which value is 1? That means this is the condition of symmetry which is matched for the short transmission line. And another reciprocity condition is that which is A equal to D. A equal to D. See here, A equal to D. So that's all for the short transmission line, the ABCD parameter calculation and how we calculate the efficiency, how we calculate the leakage, how we calculate the regulation of the transmission line. So corresponding, we can see how the short transmission line is performed in particular case. So today up to this I have said, and in next class I shall go for the another part. And thank you.